This is the research presentation of metabolites ergothioneine as forensic marker bloodstain, which will be presented by Group 4. The main reference that we used was published on 14 December 2022, and the given title was Validation of the metabolite ergothioneine as a forensic marker in bloodstains. Ergothioneine has been suggested as potential forensic marker, but its applicability has not yet been quantitatively validated. Therefore, in this paper, quantitative analysis of ergothioneine in bloodstains was conducted to estimate the age of bloodstain and that of bloodstain donors. So what is metabolites? Metabolites are endogenous or exogenous small molecules less than 1500 dalton in size. Example of metabolites are lipids, peptides, nucleic acid, organic compounds, and drugs. Those molecules are caused by the degradation products or large molecule in the blood like proteins, DNA, RNA, and etc. when the blood was out of the body. Also, metabolites can be intermediate and final products of chemical reaction, and they degrade slower than other components of blood. Is analyzing metabolites really beneficial for forensic science? The answer is yes. It can give estimation of the age of bloodstains and that bloodstains donor. It slowly degrades and exhibits significant change over time. Therefore, metabolites not only important tools to reconstruct crime scene, but it can also be used as internal standard related to the bloodstain volume.
What is ergothioneine? Short form for ergothioneine is ergo. Ergo is naturally occurring amino acid which is derived from histidine. From the molecular show, the chemical formula is C9H15 and 3O2S. The sulfur is located on the imadoxine ring. Ergo accumulates in red blood cells, bone marrow, liver, and kidneys. It is a colorless and odorless compound. The main source that we could obtain the ergo from is mushroom. It can be acquired as a diet. There are advantages of ergo that have been found in several researches. First, it could estimate the age of bloodstains. Next, ergo was demonstrated to increase longevity and overall health based on research according to Alzheimer's disease. Furthermore, it is the best indicator of lower risk of cardiovascular disease and mortality. Last, it can be absorbed effectively after an oral intake and be transported to many organs, including the brain. Okay, now let's move on to the research objective. There are three objectives for the research: the validation of the metabolite ergothioneine as a forensic marker in bloodstains. First, to conduct quantitative analysis of ergo in bloodstains. Second, to differentiate the concentration of bloodstains between elderly group and youth group. Third, to determine whether ergo can be used as potential marker in the reconstruction of crime scene.
Okay, let's move on to the part about the method. The journal say that it is a try at figuring out how to work. Blood from young and old people was used to map bloodstains, and their metabolite extraction and target measurement were done. The first step is to get a gathering of samples. People took small amount of blood from their feet. Everyone in the group fasted before their blood was taken. This study included 20 young people, 50 older people, 14 guys, and 21 women. However, 11 of the older people were sick. Blood was taken with a tube that did not have any anticoagulant or any other additive. Next was sample preparation. Metabolites were extracted from the bloodstain on the day 1, 2, 3, 5, and 7. The sample solution minus the pellet was filtered and centrifuged for 20 minutes to extract metabolite from bloodstain. The dry supernatant was filtered to eliminate contaminant and extract the metabolites. The supernatant was transferred to a tube for long-term storage after 10 minutes each of vortexing, sonication, staining at room temperature, and centrifugation. The quantification of ergothioneine part, compound optimization yield, collision energy, declustering potential, collision exit potential, and entrance potential number, establishing the approach. 9 calibration solutions were made by diluting common standard in HPLC grade water. The calibration solution made the isotope level standards, internal standard. The calibration curve concentration calculation formula quantify sample metabolites. ergothioneine in the bloodstain was quantified using mass spectrometer. Ethylene sorbate ELIPS plus C18 was the analysis column and stable bond C8 protected it. Water and acetonitrile were mobile phase A and B, 100% A gradient from 7 to 10 minutes. Multi-quad software calculated multi-polarization monitoring signal peak. The calibration curve concentration calculation formula quantifies sample metabolites. The last part under methodology is data analysis. Quantitative results were analyzed and illustrated using GraphPad Prism. On D0, the Mann-Whitney test compared ergothioneine concentration by age and sex. Figure below show Mann-Whitney test result. A repeated measure ANOVA or Friedman test was employed to examine the cis bloodstain age conditions ergothioneine concentration. Pathway analysis was performed using the Meta-CYC open database as the pictures shown below.
As for the results, we will see the concentration of ergothioneine in fresh blood for two groups of elderly people and youth. The above graphs showed a sex-separated group and same age group against ergothioneine concentration. In both cases, we can see that the concentration of ergothioneine in male is significantly higher than female. Let's take a closer look at the last graph. This results in ergothioneine concentration in fresh blood on D0, where ergothioneine concentration in male overtook female. Both diagrams show the relationship between donor age and ergothioneine concentration in blood stain. The red bar represents the elderly. From the graph, ergothioneine concentration decreased from day 1 to day 2, and it took a turn by increasing from day 3 to day 7. Meanwhile, the blue bar is the youth. The concentration increased a little to day 1, but it declined at day 2 and stayed constant until day 3. However, it rises again at day 5 and dropped at day 7. Moving on to the discussion, ergothioneine accumulation in red blood cells increases along aging. The factors affect the increases of ergothioneine concentration is diet, changes in transport function of OCTN1 transporter, as well as microbial biosynthesis and histidine absorption rates. So in this study, significant difference between day 0 to day 3 observed confirmed the change in ergothioneine concentration according to age range. Thus, ergothioneine concentration have the potential as marker of elapsed times since deposition of blood stain for a limited time. However, in various environment factors, the concentration may change due to the biochemical reaction in the blood stain.
In conclusion, we can learn from this journal the fact that the average amount of ergothioneine in blood stain over 7 days was higher in older subjects was statistically significant, proving that age classification was possible. Also, the change in ergothioneine concentration as the blood stain got older was statistically significant on day 2 and 3, but not on day 0. The results show the ergothioneine could be used as marker to measure the age of both the blood stain donor and the blood stain. Follow-up studies that are helpful and prove the link between, first, how much of the precursor in the source blood, second, how much ergothioneine there was in the blood stain, and the last one, the mapping of ergothioneine in an in vitro environment. Lastly, if the ergothioneine found in the blood stain could be used as a level better, it would help in forensic science.